Hi, my name is Michael Dow, and my final project is IMU Dead Reckoning. So the first step to this process is finding the peaks and the number of steps. On the screen is some code used to do this. The first step is getting the magnitude of the accelerometer data and translating it from XYZ to one value. Then I ran a low-pass filter over the magnitude of the data to eliminate the higher frequencies, since steps are typically lower frequencies. Then I ran my code, my step counter method over the filtered magnitude. This searches for peaks, which is when the data goes up and then immediately down. The peaks also have to be over a threshold value, and the other requirement is it cannot be within a set time amount from a second peak, which can help with not so great filtering. Here's an example of the filtering, thresholding, and peaks detection on a set of data. And this is what it looks like over an entire data set. The next step is finding the rotation matrix from the initial acceleration. The acceleration given to us is in the local reference frame, and we need to find the rotation matrix to translate it to a global frame. We know the initial acceleration is static, so it should just be the gravity vector. The goal is to find the rotation axis and the angle of rotation. The rotation axis will be the normal vector to the initial acceleration, and the gravity vector is in the global frame. Here is some pseudocode showing the process. The normal vector is just the cross product of initial acceleration and the gravity vector. And the angle of rotation can also be found using the formula on the right, which is just the angle between these two vectors. Then we can calculate the rotation matrix from the rotation axis and the angle using the equation below. The next step is finding the walking direction. We can find the swing angle of a given step by integrating the gyro data over that step. The integration will give us the swing axis in the local frame, and we can translate that over to the global frame. We first integrate the gyro data between two peaks, which is one step, and then the rotation vector of that integration is the swing axis in the local frame. Then we use the rotation matrix we found earlier to rotate the swing axis to the global frame. Finally, we rotate it 90 degrees to get the walking direction. Now we can use the walking direction to find the next coordinates of the trajectory. I assumed a step length of 1, so the next coordinates were simply the unit vector of the walking direction added to the previous coordinates. We also update our rotation matrix for the next step by integrating the gyro data over that step.